let's get going. Um, all right, so I think we'll just kind of pick up where we left off last time. We did not have, we've been still going like relatively slowly in terms of concepts we're covering, but I think that's good overall. Um, so today, I think though we'll kind of ramp it up a little bit. Okay, so if everyone remembers, here's I'll open this up in a text editor. That's the code that we generated last time. I think I opened this up in a graphical text editor before, but just to quickly show you what we had last time, I just opened it up on the command line. So we had this basic little Python script, only about 15, 20 lines, that if you recall what happens when we ran it. Oh, is this, let's see, this is the resolution you can all see, right?
Yeah.
Okay, cool. Yes, this looks like it didn't default back to Super HD. Okay. So we had this code that counted down from however many cookies. We said we had down to 0, right? And we talked a lot about the fine details of that. So I figured this is something like last semester when we were kind of piloting all of this. Let's see if I can get back. We didn't bring it until later on, but I think I'll bring it in earlier this time, which is to show you guys a debugger, which is, if you're not familiar with a debugger, it is basically most programming languages or programming environments have some kind of debugger you can run. Like in MATLAB, it's sort of built right into the MATLAB program. For Python, you can like get Python code editors that have a debugger built in. So this is an example of one that Josh recommended to me last semester, PyCharm. It's free if you want it.
How do you spell it?
PyCharm?
PyCharm.
Pycharm, yeah. So the idea of the debugger, and actually usually a debugger is part of what you would call like an integrated development environment, or IDE, which is basically like a text editor plus other tools for doing stuff with your code. So like a text editor with a debugger built in. CyclePy, if you guys have used CyclePy, is like a very basic IDE in a lot of ways because it has like a place to edit your code and a place to like run your code. But it doesn't have a nice debugger as far as I've ever noticed. So what a debugger does is like, well, normally when you run like a Python script, so I've gone ahead and opened up in PyCharm, I've opened up that script that I just showed you guys. Let's view, where do we turn on line numbers? What crazy, anyone see it? I'm looking to turn on the line numbers in this upper part.
Oh, right click on that bar.
What kind of crazy IDE? Like line numbers are like thing one in programming. I don't know why it doesn't always turn that on by default. Okay, yeah, the interface to PyCharm is a little strange, but it is free, so whatever. So what it does is, normally when you run through this script, this 17-line script, it just like does the stuff that you have, that you're instructing Python to do, right? What a debugger does is stop whenever you want and like pause the running of the program, which is a super useful thing to do and let you kind of inspect what's going on as it happens. So like easier than explaining what it is, it may be easier for me to just like do it. So the first thing I did here, and I can undo this and redo this, is you'll see in line 1 here, one thing I did is I clicked there, and this is probably roughly how it works in most debuggers, although the details vary. But what clicking there does here is sets what's called a breakpoint, which means basically like here's a place where the code will stop for the first time. So when Python gets to that line, it will kind of stop hammer time and say like, all right, like I'll pause here because if you have a more big complicated program, if you have like a 1,000,000-line program that you're trying to debug, you obviously don't want to like stop at the very beginning and like trace through everything that program does. Maybe you just want it to stop like right before where a bug is going to happen or something like that, so you can figure out why, right? But in this case, I'm going to set a breakpoint in the very first line so that when I start debugging, it will stop the code execution on that very first line and we can see what's going on. So, well, let me just do it. So what I'm going to do is say debug example 01. All right. So this is going to do some stuff. It's going to show things of interest to us down here. There's nothing really of interest to us yet. This is some like Python internal stuff that you don't have to really worry about too much. I mean, you can kind of guess what some of this is, right? Like it's got a little internal variable called like file saying what file it's running and things like that. But the main stuff that's interesting to us will happen once we execute this line of code, okay? So what you can see here is we've got this blue line here on line 1. And that kind of tells you where Python is right now. And where the blue line is kind of is what it's before. So in other words, it has not yet run line 1. But when it does, it'll move the blue line down to line 2, and we'll go from there. So just as like a simple refresher. So what's going to happen when we execute line 1 here with Python? What will happen as a result of that line?
It'll make cookies with the value 5.
Okay, so it'll make a variable named cookies. That variable will have the value 5. So what I'm going to do is use the debugger function called step over, which just steps over that line of code and runs it. I mean, so it doesn't step over it in the sense of like not running it. And you'll see, here's what it did, right? So the difference is now in our little pane here called variables, you see that it's got a new variable named cookies, and it currently has the value 5. And I think we can, let's see. Does PyCharm let us? Yeah. So if we mouse over cookies, another nice thing in the interface is in the code, it'll kind of tell us what value that variable currently has, right? Anywhere that we mouse over, I think if we mouse over cookies here, yeah, it should work that way too. Okay, so that has made our variable cookies with the value 5. Now we're on line 2. What's going to happen when we run line 2?
Company will be equal to the cookie company.
That seems reasonable. Let's try it. Okay, so we have a new variable here called company. It has the value of the cookie company. And you see that also it tells us the type of the variable, right? So this is a string variable. And, you know, again, if you mouse over up here, it shows us what company currently is, right? All right, so line 3 is a print, so it's just going to print out something, right? So we'll step over that. And if we want to see what it printed out, you know, you see we've got like tabs down here. So here's like our console of like what Python actually, you know, would spit out to our terminal window if we were running this through the terminal. So that's our output, right? So the debugger is just like what we're using to kind of peer inside the program as it executes. We can step over the next print line as well. There's not too much interesting going on there. We can check and see in our console that I got 5 cookies, yay.
Keep your variables in alphabetical order? Like, why did it put company over?
That appears to be the case. Well, let's find out. There might be a different way to sort them. I'm not a huge PyCharm user.
Oh.
Yeah, well, I mean, added cookies, it looks like it put before the others. So yeah, probably just alphabetical, I'm assuming.
There's a good way to do it, though,
I think it's
right?
Well,
I guess it doesn't matter what order you save them in, it depends what order you call them.
well, yeah, I mean, I guess you could see where it might be useful to like see what was changed most recently at the top or
So,
something.
Matt, I'm confused. What part of this is PyCharm? What
PyCharm is the application that I'm running.
But this is CyclePy?
No.
Oh, PyCharm is another thing.
It's another old thing. Yep.
Oh, okay. I thought.
So PyCharm
okay,
and
got it.
CyclePy are both like application packages that like run Python code
Got it.
and like have an integrated editor in them. You know, CyclePy is obviously built to integrate with like all the other CyclePy stuff. PyCharm I'm running now because it has a debugger which lets us like do this line by line step through thing.
So would you like copy and paste this syntax into CyclePy eventually, or does this also have this like? Are they like 2 separate things, or like?
Well,
I understand that they both run Python, but
yeah, I mean they're both using the because like Python itself, well, Python refers to like the language, like like English is a language. You know what I mean? It refers to like the idea of Python, but it also refers to like the program Python that you can run on your command line if you have a Mac or Linux machine, or if you've set up Windows the right way. Like both PyCharm and CyclePy run Python stuff using the Python like kind of base level program, but then they kind of add this interface on top. So there's some tricky bits, like, so, part of what CyclePy is I think CyclePy actually, when you install it, actually installs a second Python installation that's like specific to CyclePy.
You can access it within PyCharm.
Okay.
You can run simultaneous environments and like select which environment that you're running.
Yeah.
So you could run a CyclePy experiment within PyCharm, but it's not really recommended because it's
Yeah.
a lot of extra stuff that you don't necessarily need.
It's
good for
But there's probably no need to. I mean, this is running Python, so why would you have to run it in
Well,
another interface?
the main thing about CyclePy that does make this a little annoying is CyclePy includes its own little like code libraries that you can like of functions that you can use. And in order, if you wanted to like run code that uses those code libraries within PyCharm, you'd have to like somehow tell PyCharm where that CyclePy code is that normally CyclePy, or is it able to find itself?
If you go to
okay.
PyCharm settings and then environment, it'll show you every Python environment on the system.
Really?
Yeah.
You can see how much I've used PyCharm.
Yeah.
I mainly used it to show off the debugger. So where is it? It's in
Project entitled.
Project entitled.
And then interpreter. And the top scroll bar, or the top.
This thing here. Oh, I see.
Yeah. So if you have.
But I do have CyclePy installed. I think
maybe, but
you probably have experience with this on a Linux system, I'm guessing.
no, on a bunch of systems.
Okay. It may work differently. I think it might be more self-contained on the Mac inside like the app package. That would just be my guess. But anyway, all right. Well, more than we needed to know.
Yeah.
Although it does show, it does show things that I know that I've installed actually myself. Like I wrote a little Google Music. Where is it? I've lost it now. I just saw it. I wrote a little Google Music.
There it is, under decorating.
Where is it? Oh, Gmusic API. Yeah. So like, that's stuff that I installed manually. So I know that it does have, like various like packages that I installed, but I don't see the. All right. Anyway, it doesn't matter. But anyway, yes, there would be some complications. It would be a little annoying to debug CyclePy code potentially, but in theory, workable. Yeah.
Is this PyCharm used for running code they've already made, or can you make code with it? Because I have it up right now, and it just mentions getting files from elsewhere. So do you not make scripts on here, you just run them after you've made them?
I mean, you can, this editor up here is like a full-fledged text editor. So you can like create a file, edit it. These are all just text files, right? So like, you can
finding that option to create something on here. So
it's kind of weird the way it like forces you to organize things into projects, sort of.
It's geared towards like mass program development, not small scale like scripts.
Yeah, I wouldn't. I mean, I'm like, I don't want to get too hung up on the details, just because like for this context, I'm mainly just using it to show you guys what a debugger is and how it is useful to like how you think about how the program runs. We can talk about the implementation details later, but yeah, like you can edit, run. I mean, if you just want to run code that's like already thoroughly debugged and existing, there's no need to launch PyCharm. You can just run it via like Python itself, like on the command line or through CyclePy or whatever. But you can just run it, right? So like when I right-clicked up here to do debug, there's another option that was just run it. So I could just run it through and like produce an output on the command line. That would be fine. But the real value is running this debugger that lets us stop and see what it's doing at every step along the way. And I should mention, like, the main benefit, I think, to doing this is, like, we talked earlier about how, like, you got to stop thinking like a human and have that empathy for the machine thing going on, where you see the code and think of it the way that the computer is going to think of it, right? And this lets you see, like, this will be more interesting when we get down to the while loop, how it thinks when it sees a while loop and how you need to start thinking about how stuff is going to work when you have something like a loop here. By the way, you'll see it also like this little just side thing at the interface, right? You see that it also does this thing where like it shows the values of variables out to the side. So don't get like hung up on thinking that's code. That's just a little thing that the interface adds on top, that appears that is not in your code file. So that's, I kind of actually don't like that. I'm sure there's a way to turn it off, but I haven't found yet. But don't worry about that. Okay, so what's going to happen though? Let's get back to running through this. So what's going to happen on line 7 here when we run that? So cookies equals cookies plus added cookies. What will be the result of running that line?
8.
What will be 8?
Cookies.
Okay, so cookies will update its value and be 8. So if you kind of keep your eyes on the variables down here, we'll run that one line of code. And yay, cookies is 8. And it looks like it
So
didn't
it
move.
does show you the last thing that changed.
Well, yeah, it highlights in blue the last thing that changed, but it's not resorting them, I guess. So that's our answer to the question. It stays alphabetical, so this must all just be pure alphabetical. That makes sense, because all the underscore, like internal Python variables are at the top, because those underscores.
The watching thing isn't alphabetical, though.
The what?
The watching window. Like, if you are interested in one variable, you'll watch it. You'll
Oh, right.
select it, and it'll just highlight that one off to the side
Oh, okay.
at all times.
Yeah, and I never used that feature myself, but good to know. All right, so let's skip through these next couple of print statements. I think you guys get how the print statements work. The real question is what's going to happen here. All right, so last time we did step through this. So we said we got a loose idea of what's happening to this chunk of code, right? So we saw if we go back to, I think we ran this in the terminal before, right? So when we ran this code, just straight up ran it without stopping along the way in the debugger, we got something that looked like this, right? So it says, I'm eating more cookies now, I'm eating a cookie, now I have 7 cookies, I'm eating a cookie, now I have 6 cookies, 5, 4, 3, 2, 1, 0, and then it finally says, now I have no more cookies. So we have a loose sense of what this does, right? Like it counts down the number of cookies. Every time it says I'm eating a cookie and gives the update on how many it has. But let's see how it actually does this, okay? So we got the statement while cookies is greater than 0. And so is cookies greater than 0 right now? Well, here's what cookies is.
Does it treat it like a true-false statement or something like that?
Yes, it's
Cool, yeah.
evaluating to see whether, so like, let's actually, so don't let me blow your minds here. But, I can run Python, the program on the command line over here. This is like a totally separate thing than my Python code that's running in PyCharm. Is that all right? So I'm not blowing anyone's minds with this. So this is a totally separate thing. I'm just doing this over on the side to show you something. So if we have cookies equal 5 or something like that, and I say cookies greater than 0, that gives me true, right? So so you can think of like comparisons or true false or things that could be true or false as just being like mathematical operations, right? So if I say cookies plus 3, that's an operation that you can like evaluate that like you would in algebra or arithmetic. And you say 5 plus 3 is 8, right? Cookies greater than 0 is also like, so, we call that plus sign like an operator, like in math, that's an operator, plus, minus, divide, times. Those are like operator symbols that do something on the values around them. Those greater than, less than, equal to, etc. things are also operators. And they're operators that instead of like adding the two things or whatever, they compare the two things and what they return instead of like another integer is a true false value, right? So like, in other words, like what the plus sign does, you probably never thought in this much depth about what the plus sign does. What the plus sign does, right, is take like the thing on the left, thing on the right, adds them together, and returns back. If you think of it as a little like function machine or a little factory machine that like takes two things in and spits out one result, it takes in the two things and spits out their sum, right? The thing that the greater than symbol does is takes the two thing and spits out true or false, depending on whether the thing on the left is bigger than the thing on the right. Does that kind of make sense?
So it's like exactly what we were doing last time when we had like the double equal sign.
Yes, same thing. So, that's also like an operator. So remember, the double equals is how we test if things are equal, right? Single equals is what we do to assign a value to a variable. So if we want to know if cookies is equal to 5, that is a little like function machine that looks at the two things and says true if they're equal, or if they're not equal, false, right? So you could even do things, you do this with literal values, right? 5 equals 4, 5 equals 5, right? So that
5
gives you,
5.5.
what's that? Oh, that's a good question. So that's false, but you could say, oh, right, because if we recall, if we do this in integer world, 11 over 2 in Python is 5. Yeah, and in the sort of like PEMDAS order of operations, equality testing is a lower priority than division, although to be like to not have to remember that, I would usually put that in parentheses just to be sure, just to make it clear that we wanted to do the division first. Because actually, let's see, wait a minute. I don't want to blow your minds here, but all right, yeah, that technically works. The reason that works is because,
That's just false.
all right, not to blow your minds too much, but why did true plus 1 give me 2? And
Binary.
yeah, false plus 1, false minus 1. So true and false are really just like words for the numbers 1 and 0. They do have like a slightly specialized meaning, but if you coerce them, if you force them to be treated as a number by like trying to add an integer to them or something, you could find out what they really are.
So what if you just type true and enter? Does it say one?
No, true and integer is just true.
Okay. Okay.
And this is a difference like in C or a really low level language like that. True and false are literally like integer values. And you can't, and they aren't, so, you know, we talked about different data types, right? So you have like integer data types, you have like floating point data types, you have like string data types that are known by Python as it's running to be different types of stuff, right? I mean, they're all just like, in reality, they're all just like numbers in bytes in memory, right? But like Python knows to treat them as different stuff. But so in some languages, true and false are not treated any differently than the integer 0 and 1. They're really like integer data types where like there's just a convention that when you type true, it really just like it's like a permanent variable where the name true always equals 1 and name false always equals 0. But Python does know to treat true and false as a different data type, even though like under the hood they're actually integers.
It's also true that you have to capitalize the T and the F.
Yeah, and that's something that will trip you up if you're language hopping all the time, because it's lowercase in MATLAB for true and false. I don't remember what it is for JavaScript or other languages. Yeah, but it flips back and forth. Python is capital. Yeah, if you just say true, if you really want to screw with someone's head, you know, you can very easily say something like,
Oh wow.
you know, and then say, does false equal true? Of course it does. Oh, no. All right. Let's not blow minds here. All right, let's go to the very simple true-false case. In where we are in the other program now, is cookies greater than 0, true or false?
Or true, sorry.
True, yeah. Right, because cookies is currently 8, 8's greater than 0. So when the thing to the right of the word while before the colon is true, what that means to Python, right, is like do the stuff in this little paragraph that's indented below me, right? I'm not sure if we really talked about this, but probably not because it's our first indented code we've really had in this. But you know, some languages have like different ways of setting off little like paragraphs or chunks of code that go together. If you've done a C-type language or something like that, you've seen that you have little braces. In Python, it's purely based on indentation, right? So these next 3 lines, 13 through 15, that are under the while statement, that are all indented the same way, those go together. Those are the things that go with that word while.
But is that a colon or?
Oh, that's a colon, yeah, sorry.
So you need that, right?
Yeah, the colon lets Python know that that's the end of the while statement. That's the end of the while line. Now, other programming languages don't require a colon at the end. That's another like little syntactic tweak of Python. Like other ones just kind of take it as implicit that at the end of the line that begins with while, like that's the end of the while test.
And there's no colon at the end of the print line, right?
There's no colon at the end of anything else, yeah, or no semicolons either. Python, like a lot of languages, every line has to end with a semicolon. Python is not such a language. I think it lets you end lines with semicolons if you want to, but you don't have to. Yeah, so all these little syntactic tweaks.
Those 3 lines were not indented. Would you get a there?
Well,
Or is it just like?
all right. Well, let's test that. Can you remind me when we get to the end of this kind of little execution of this to test that out? So hit me up again in a second. All right.
Yeah.
All right. So we've decided that our condition is true for the while loop. So if we then step onto the next line of code that's going to execute, you'll see it jumps into line 13, right? So line 13 should be obvious what that does. It prints I'm eating a cookie. If we want to check back at our console to see where we are, like that's all the stuff we've printed so far. And now I think we know, so what's going to happen if we execute line 14 here, which is the line we're currently on.
cookies will equal 7.
Okay, yeah, so cookies is going to get itself -1, which is 7. So step over that. That is correct. Now we see the cookies have been updated to 7. It'll print, now I have cookies, cookies. All right, so actually before I do this, where is the code execution, do we think? Where is it going to, like, where is this highlight going to go after we run line 15?
And evaluate the true or falseness of the while statement.
Okay, that's a good hypothesis. So let's try that. Excellent. So this is what you have to start getting used to is like, typically, again, we said before, I think, that like, you gotta stop thinking like a human that can kind of see the whole file of code all at once and like ascribe meaning to it in its global sense, right? The program, Python, only sees like kind of one line at a time and does exactly what it's told. But of course, like if it just had to go like linearly straight down without any kind of logic or, way to kind of direct what it does under certain circumstances, it would be impossible to like write any kind of like logical or repeated operations into your code, right? So yeah, so when you've got stuff in a while loop, which is what we call this, right? A while loop. When it gets to the end of all these statements that are under that while statement, it goes back to the top. So that's a case where it doesn't just like read straight through the file. When it gets to the bottom of the stuff under while, it knows to go back to the while and recheck the condition, right? So is cookies greater than 0? True or false? True, right? Because cookies is now 7, but that's still greater than 0. So it's going to go and do the stuff inside the loop again. So if we do this again, cookies is now, after line 14 this time, is going to now be what? 6, right? Okay, so good. Cookies updated 6. Where's it going to go after line 15? What line number will it go to? Should go to 12, right? Good. It's going to check the condition again. Is cookies greater than 0? True. So all right. So does people see how this is going? So it's going to, check the condition each time. Cookies is 4. Cookies is 3. And we can check back at the console and see that it's printing out, I'm eating how many cookies each time. Step through, step through, step through. Okay, cookies is 1. 1's still greater than 0. I'm eating a cookie. What happens after line 14 here? Cookies is now what? 0. All right, so now what happens after I execute line 15? Where does it go?
Still has to go back to line 12.
Okay, it's in the while loop or the while kind of chunk of code. Right, so it goes back to line 12. Is cookies greater than 0? No, right, it's equal to 0, but it's not greater than 0. So that is now false. So where is it going to go when I click the button to go to the next line of code?
Print, now I have more cookies.
Indeed. All right, so when the like condition that while statement is predicated on is false, then it like jumps over that whole loop and goes to whatever's after the loop, right? Obviously it skips the blank line, 16, because there's nothing on 16. It goes to 17, and so after we do 17, what happens?
It just stops.
Yeah, yeah, we're done. Yeah, that's the end. So, we can go back to the console and see what we printed out. All right, and it tells us that means like there's no error to the process, but whatever. Yeah, so that's all the stuff we printed. Does that kind of make sense to people how that works? Like how it's, if people have written stuff with while loops before and not kind of looked at it with this debugger, maybe you're used to thinking of it, like if you're telling a human like, keep eating cookies until the box is empty or something like that. You're kind of saying the same thing, right? But the human has like sort of a high level understanding of what that means. They're not like literally kind of executing a series of steps as a human, right? That's like, I ate a cookie. Now I will check how many cookies are in the box. Now there's 0. You know what I mean? Like the human knows, like when I tell you, or if I say like, something like, you're driving and the rule for driving is like, while you have not encountered a red light, keep driving straight. You know what I mean? Like you're not like as a human going like, I'm going to drive 1 meter and then check and see if there are any red lights. I'm going to drive 1 meter and see if there are any red lights, right? You have sort of like as a human, you know to like terminate what you're doing when the thing becomes true, right? So let's actually just like do a super quick version of this again because there's a fine point to note there. So let's debug this again, and then we'll get back to the question about how the code's indented. So let's go through all this again. Cookies is 7, 6, 5. All right, so let's say you're a human. I mean, you are human, hopefully. And you are, I tell you to like do this stuff, while cookies is greater than 0. This is a kind of fine point that might have not been noticed this last time. So now we're down to the point where cookies is 1. It's going to say, I'm eating a cookie. It's going to make cookies 0, right? Now cookies is no longer greater than 0, right? That while statement, that statement that the loop is predicated on is now false, right? But it doesn't immediately break out of that while statement, right? Like, so it has so far printed all this other stuff, right? Now I have 1 cookie, I'm eating a cookie. If it just stopped as soon as that became false, this would not get printed, right? But it does because it doesn't check that condition again until it loops back up again, right? Does that kind of make sense to people? So like if you were a human and I said like do all this stuff while there's still cookies left, presumably as soon as the cookie got eaten, you would stop doing whatever it was you were supposed to be doing, right? The program though doesn't actually check the condition until it gets to the end of that group of statements into the while loop, right? And goes back to the top. Does that make sense to folks? And that's, I think, something people forget oftentimes is that if they have like a while loop going and the thing becomes false like midway through the while loop, it's still going to keep going until you get to the end of all the stuff under that while statement because it only goes back to check when it gets to the end of all the stuff under the while statement, right? Okay, so let's so then it's going to check now and not do this other stuff. Okay. So let's try the thing about, so what if we didn't have, like, say, this line indented? Whoops. Oh, no. More than I bargained for. Okay. So let's say we just did that. I'm going to save it. So how is this going to work if we debug this one? So let's.
I think that's why Wanda asked if there's a colon at the end of the loop, because now, like, I think the indent tells it where the loop starts and ends, so it's gonna keep doing that loop, but it won't print off that line 15 until the cookies is less than 0. The state is true or false.
I think that's a fair guess. So what I also did here is I just moved my breakpoint down. You can have multiple breakpoints, but let's say I'm pretty sure that the code in lines 1 through 9 is doing what it's supposed to. So if I just want to stop and pause for the first time on line 11, I can do it this way, right? So if I like debug now, see, it's going to like do all this stuff up here. It's going to go ahead and make cookies 5. It's going to go ahead and add 3 more cookies there, make it 8. It's going to print all that stuff, so it's already printed like I got some cookies, I got 3 more cookies, right? It has already done that stuff by the time it stops here on line 11. So that's, the utility of these breakpoints, right, is like you don't have to always go through every single line to go through a certain set of your lines. Okay, so while cookies is greater than 0, cookies is 8, that's greater than 0, it's going to print that, cookies equals cookies minus 1. So where does it go after line 14? What line does it go to after this? Very good, right. So because that is not indented, in Python's world, that means that line 15 is not part of that while loop. So, what we get in the console, right, is just I'm eating a cookie, I'm eating a cookie, I'm eating a cookie. But it's not giving us like the actual number status update, although it is, decreasing the number of cookies each time. Cookies is not greater than 0 now, right? So that's going to end the while loop. Go to the next line after the while loop, which is 15. Print that just the one time and get out, right? So that's exactly what we said, right? So it just says I'm eating a cookie, now I have 0 cookies, and that, right? Does that make sense to people, like how that actually is working? Any questions? so far. I mean, I know this is going like relatively deep dive into like what a while loop is, which is a pretty fundamental programming concept, but it's good to like get a sense of this. Any questions so far?
What other examples of like logic statements can you do in C++?
That's a good question. Well, so let's do it this way. Let's add a little bit. I'm gonna actually say this is like a new stopping point after, so that we can just like elaborate on this but not lose the old stuff. Oops, that's not 12. I did that wrong. Well, let's quickly rename that here. And because it's mirrored, I rename this way. 1, 2, example 02.5. Okay. Let's try it again. Oh, let's just do it this way. All right. All right, so here's the same file, but duplicated. Now it's example 2. So let's do it this way. All right, so we're gonna add a bunch of stuff here. Okay, do that. And let's just add some other fun stuff in here. Let's see. Oh, wait, actually. Cookies. Not 12. This is not all going to make sense. We'll probably have, like stop. We'll probably like pick up on this next time and kind of walk through it and see what it's doing. Okay. Let's see if this works. First of all, I'm not totally sure if it's going to. Let's see. Let's actually make this more like 19. All right. Let's see what this does if we run it without debugging. See if I did this at all right. Okay. So let's make our little window bigger here. Okay, that's exactly what I wanted to do. All right. So we see something different is going on here, right? And we've added a couple different concepts here, right? So we've added a for statement, which if you program for may be familiar to you. We've added an if statement, which again may be very familiar to you because that's part of a lot of languages. But if you've not really thought heavily about these things before, haven't seen these before, we'll go through this now. All right, so we didn't change anything up to like here, right? So let's first of all turn our damn line numbers back on. Okay, and let's debug this and sort of start to just break down what's going on here. So let's maybe just step through this a little bit, and if this is unfamiliar to you, just see if you can kind of intuit what's happening here. So we've done all this stuff down to line 11, right? We've stopped before running line 11. You can see that we've still got a variable called added cookies, which is 3, company equals the cookie company, cookies is equal to 8, which is an integer. So let's just see what happens if we start kind of running through this code. Well, first of all, it's bouncing back and forth between lines 11 and 12, right? Which means we have another thing, and from the indentation you can also tell us, we have another thing that's like a loop type thing, right? That's going to run not just like linearly straight down the page, right? But it's going to like bounce back to a previous line at some point. So that's something we can tell. So that's going to happen a certain number of times. Oh, looks like it's done. Okay. And now we get through here. A lot of this is similar to before, but this is kind of new. Oh, it looks like it got to 19 and it didn't do line 20, so that's interesting. Oh, but wait, now it's doing line 20. That's weird. Okay. Okay, but now it's not doing line 20. Okay. Let's see. One more time. Wow, it doesn't really like. Oh wait, it just ran line 20. Okay. All right. So let's see, which one is the, all right. I'm just gonna that just lets it finish. And if we look back here, that's what it printed out, right? So it printed out a bunch of, I'm eating cookies. It occasionally printed out, now I have 2 dozen cookies, now I have 1 dozen cookies, now I have 0 dozen cookies, then it ends with now I have no cookies. All right. So what's going on here? So let's debug this again and like think about this. Starting with line 11. So what does this for statement look like it's doing?
I mean, it looked like it was just doing what's under 19 times. I don't know what CPR is.
It's a pretty accurate statement, I would say.
Did it stop at 18 though? Does it start at 0 or something?
All right, so this is one of the many ways in which Python is a little weird, and I think this is worth stepping through. So maybe we'll get to like just a little bit of like what Python's actually doing when you have a for statement, and then pick up on this next time. So let's again, don't freak out. New Python over in the command line. Totally separate from what's in PyCharm. All right, so let's try some stuff over here. So let's say first of all, let's try this. So we have that range thing. I had in there like range 19. So if I just put in range 19 by itself, all right, that's what I get. Let's try like range 12. Let's try range 4. Whoops, that was 14. Let's try range 4. All right, so what is this, just by itself, what is that range statement doing?
A spread of how many values.
Yep, it's making, well, we haven't used this type of data yet in Python, but I'll tell you about it now and we'll talk about the details later. There's another type of variable in Python which is a list of other things. So we could actually take this range statement. So if we wanted to say, make a variable or something, call it nums, equals range, let's say 4. I can do that, and if I want to see what nums is, that is a list of the integers 0, 1, 2, and 3, okay? So what that range function does, which is, range is a function that's like baked in deep into Python. So it's something we have access to like in all Python installations. Range returns a list of numbers. So if we did range 19, we got 0 through 18. We got range 12, we got 0 through 11. So it returns 0 up through 1 less than the value you give it, right? Which is a little weird to get used to. In other words, range 19 gives us 19 integers starting with 0, right? Does that make sense to everyone? Because 0 through 18 is 19 numbers. You might think it goes from 0 to 19 or 1 to 19 or something like that. You would be wrong in both those cases. It gives you 0 to 1 less than the number you put in. Okay, so that's one thing. Now let's try something. So let's just do this real simple like for, let's just call it I in range. Let's just say like 5. Got to indent just like with while. All right, so that did that, right? So what do we think is happening when we say for I in range 5? And then obviously print I is going to print whatever I currently is, right? So somehow we're defining this variable I. Can anyone interpret what that for statement is really doing? This is tricky to put into words if you're not used to this stuff, but give it a shot.
Setting I equal to each integer in that list in the order that they're in the list. I don't know how to say it. And then print.
Yeah, that's a very good way of putting it. All right, so let's try a couple different variations and see if that makes sense. So
Is this like the basis for an array, basically? Or is it a little bit different?
another word for this list would be an array. I mean, there's some fine distinctions between what you call an array or a list in various languages, but yeah, the list is basically an array. So an array is a list of things. Python uses the terminology list. C uses the terminology array. MATLAB, it would be a matrix, but same idea, right? Like any list of items. So, whoops, for I in, now,
So you could like do math with it and like.
oh, you can do all kinds of stuff.
Alright.
So what's going to happen here when I run? So when I hit enter again to like tell it that I'm done entering stuff under this for loop, which this is how you enter for loops in the Python, like typing code directly in, right? Is you have to like give it a blank line at the end to let it know you're done typing indented lines. What's going to happen here? What's it going to do?
What's nums?
What is nums?
Range 4.
Well, we got it by entering range 4.
Oh,
and
no.
what is nums that we made up above? Yeah. We said it's a list containing what?
0, 1, 2,
Uh-huh. So what's going to print out when I run this?
0, 1, 2, 3.
Seems like a valid guess. That is correct. All right, let's try this. Make a new variable. Oops. All right, so if I want to see what nums2 is, that is also a list. So you know it's a list because it's got these little brackets on the outside and it separates stuff with commas. What does this appear to be a list of?
Strings.
Yeah, so now it's a list of like strings or character strings or text or whatever, right? So now, if you want, actually, I can blow your mind even more. If you can even handle this amount of mind blowing. Whoa! Wait. Okay. So now, so actually lists can have all kinds of stuff in them, right? So we've got, this list has 3 strings, an integer, a floating point number, and another string in it, right? And that's cool. Lists, unlike C or MATLAB, if you use those, lists or arrays or whatever you want to call them can have data of different types in them, right? So like the first thing in that list is a string, the second thing is a string, the third thing is a string, the fourth thing is an integer, the fifth thing is a floating point, sixth thing is a string, right? So what's going to happen if I do this now?
Still gonna print it because I doesn't care what type of variable it is. Could be wrong.
It's a pretty good guess. I would say you were right. All right, yeah. So I think you guys have sort of figured out what the for loop does is what you're really doing, and this gets glossed over, I think, a lot when you first start doing this stuff. And this is, I will warn you, it is different in different programming languages what this for loop really means. So, what a for loop does in basically every programming language is it does a sequence of things a certain number of times according to some specification. It's a very vague thing. So unlike while like just checks to see if a condition is true, right? And you can do anything inside that while like paragraph or that while statement or that while code chunk to like eventually make that condition become false, right? For loops, the difference is they run typically a set number of times, right? And so what happens each time through the for loop is this I variable, right? So this I variable, which did not exist before the for loop, or did not exist before the first time we used it in a for loop, it automatically creates this variable that is called I, and it takes a list of values, which we can either make ourselves, like we did up here, or we can get the range statement to make for us. And it says, all right, each time through this loop, I'm going to set the current value of I to the next thing in the list, right? And I'm going to keep doing that until there's nothing left in the list to assign to I. Does that kind of make sense to folks? All right. So if we go back to now, this is like going deeper into the for loop than like you usually do it, because like I would say probably, well, less so in Python, but in like typical programming, like maybe 90% of the time, what you're doing with a for loop is just trying to make something happen a certain number of times. So like here, when we go back to the cookie code, stuck here on line 19, we say for CTR, which I'll pronounce counter. For counter in range 19, cookies equals cookies plus 1. Keep in mind that cookies is currently 8, based on what happens in the first 9 lines of code. So like loosely speaking, and just kind of like human ease, English you might say, what is going to happen as a result of that for loop in lines 11 and 12?
So CTR is the same thing as I. It's just you're calling it like whatever you want. So it's not
Yeah.
actually something in Python. It's something you just.
Oh yeah, I counter. You could call it Billy Bob. It can be whatever. Like that's just so. What that's doing is that's giving a name to a variable. Well, so actually, this is a good point. So here you'll notice I didn't actually use counter in line 12, right? Here I did use my like counter variable. Often you call these like a counter variable because that's what they do is they kind of like keep track of the current like iteration you are in the loop. Like here I used it, right? Like so what's really happening in each iteration of this for loop is there's sort of an implicit like I equals next thing in the loop or next thing in the list, right? And here like counter is going to in sequence be like first 0, then 1, then 2, then 3, then everything up to 19.
Well, it is like a list though that you have like the 0 through 18, and it's just using that list as a counter.
Right. So in this case, we don't really care about the actual like value. You know, it's like those little counters they use when you're like walking to an event or something. It's like counting how many people go in. Like sometimes you care about like what if you're going to give out a prize to the 100th person, you care about like what value the counter has. Sometimes you just want to make the thing happen a certain number of times, right? So yeah, in this case, we're not using the counter variable, but still it's going to get a value a number of times in that list.
Does the counter variable get terminated after the loop? It doesn't.
Well,
Like if you did
that's a good question.
CTR outside the loop, it
Well, what do we think? Back in this example, what do we think I currently is?
6.
That's correct.
Well, it's the string 6, so that's weird. Is it just doing the
Well,
last thing?
that was the last thing that was in that list that we were looping through, though, right? So, yeah, so the counter variable does not go away at the end of the for loop, and that's true in most programming
So
languages.
then if you do 2 for loops in a row, it just reassigns the value.
Right. So the for loop, yeah. So that's a good. Oh, so many good questions, right? Yeah. So if we were to like go and do back and do like the old for loop that we had before, right? Like for I in nums, where nums was like 0, 1, 2, and 3. Now print I. Now what is I? Now what am I? I am 3. Yes. Right. Because yeah, that for statement has like an implicit like I equals whatever every time you see it, right? So yeah, it doesn't matter that I was 6 right before the for loop. Now I, in sequence gets the values 0, 1, 2, 3. At the end of that for loop I just put in, it's still 3, right? Until I can just use it like a regular variable after this, right? I could just say I equals 7 now. And I 7, right? Like it's just a variable, but it's a variable that's sort of like auto-created and updated by that for loop. Okay, so loosely speaking, so back to lines 11 and 12 here, maybe we'll wrap up here and not get to that crazy if statement stuff down below. Loosely speaking, what is the outcome of running the code in lines 11 and 12? So like what's going to be sort of if I like set a breakpoint here, take away the old breakpoint, and just run the code until it hits line 14, what is going to be the effective result of that loop in lines 11 and 12?
It's going to add 19 to cookies, to the original cookies.
Right, so it's going to increment the value of cookies by 1, 19 times. And so cookies should go from 8 to, I think, 27, right, if we've done the math right. So let's see, let's go to, what is it? It's
I think it's the play button on the left.
the notation. Okay, thank you. Yes, continue. All right.
Yeah, it's not
All right.
the number in the range.
Oh, right. It's not
It's
CTR.
zero.
It's iteration 0,
But
but
it's
it's still
19
adding 1.
times.
Yeah.
All right. So we were correct, right? So do we all come to that consensus? So if we are on line 14 now, counter is 18. So it ran from 0 up through 18 very rapidly. Cookies got equal to cookies plus 1 19 times. So whereas it started out 8, then it incremented itself 19 times, it became 27. Is that still making sense to everybody so far? Everybody cool? All right. Shall we stop for today and leave a cliffhanger as to what? I'll leave this. I won't touch this computer for a week. So we can resume
Should we leave
exactly
our
here.
computers too?
What's that?
Should we leave our computers too?
Yeah, nobody move. We all just have to sit here for a week in Carbonite. All right, cool. So we'll pick up next week, kind of like figure out what's going on with that if stuff, that crazy parentheses. I mean, not parentheses, percent sign thing going on in line 19. So we'll talk about some more of that later, but hopefully for loops. We have now gone into for loops in like gruesome anatomical detail, but hopefully they make some sense to you. We'll talk a little bit more about what they're useful for in the future. So any other like final stuff on the record before I stop the recording? We good? All right.